Alright, this problem is from Cutnell Johnson Physics, 7th edition. It's from Chapter 3, problem number 31. I'm going to work through this problem with you, and I want to encourage you to do what you can on your own. However, use the video to help you through the tough spots, or if you just are not sure about what to do in a specific point in time. So let's go ahead and start off. We're going to go ahead and draw what we know so that we know what's going on here. So we've got a rocket that's being fired at 75 meters a second. So here's my rocket, right? And it's being fired off at 75 meters per second. And it tells me that the angle is 60 degrees. So this right here is 60 degrees above the horizontal. It's fired towards a wall, so we know it's going to fly up in the air. It's fired towards some wall, which is down here. The wall, it tells me, is 11 meters high, and then from here across is 27 meters away. Okay? Now, this other stuff, the rocket attains its launch speed in a negligibly short period of time, da-da-da-da-da-da, that's just saying that this acceleration of the rocket launching happens very quickly. So we can assume that from 0 it has this initial velocity of 75 meters per second. Okay? Now, let me encourage you to, right off the bat, go ahead and break this vector down into components. We know that our kinematics equations only work in one dimension at a time, so we're going to take this and break it up into x and y components. Okay, so I'm going to bring up my calculator. I know that to get the adjacent side I'm going to need to use cosine, so that will be 75 cosine of 60, which is 37.5. So 37.5, many of you knew that because of special triangles. 30, 60, 90 triangle. And then the other side is going to be 75 sine of 60. Alright, so that will be 64.95. So 64.95 meters per second. Okay, so now from this point, let's list the information that we have and see what we can get. In the x direction, we now know the initial velocity, 37.5 meters per second, is the velocity in the initial x direction. Okay. Now, since it's projectile motion, nothing is causing it to speed up once it's in the air, right? Told us that the acceleration happens right at the beginning. So once it's in the air, its horizontal velocity is going to stay the same the whole time. So my final x velocity, no matter where that is still going to be 37.5 meters per second. I also know what I'm looking at right here is I'm looking at starting here at the very beginning, and then it's asking me about something, some information right here where it clears the wall. It says by how much does the rocket clear the top, so how much extra space do I have here. And so I know that the horizontal displacement that I'm looking at is going to be this 27 meters. Okay. I also know, of course, that the acceleration in the x direction is 0 meters per second squared, and that's all I know. Okay. In the y direction, I know the initial y velocity is 64.95. I know that the acceleration in the y direction is negative 9.81. And I know that, actually that's all I know because I don't have the time. I don't know exactly how high it is at this point in time. You don't want to calculate any other point in time. You don't want to do right here, which is the top of the arc. You don't want to do at the end where the displacement is back to 0. Okay, so this is really all you have for the y's right now. And so it looks like I have a lot more information with the x's. I'm going to start off by calculating the time given the information that I have with the x's here. Okay, and I'm going to use the kinematics equation that looks like this: v equals v naught plus Actually, I'm not going to use that one because that one has 0 being multiplied by the time, so I can't use that one. Let's use this one right here. So x is equal to 1/2 v initial plus v times the time. Okay, and so let's use this one, and we're going to solve for time here. So we're going to put 27 in equals 1/2 times 37.5 plus 37.5 times t. Okay, so that means 27 is equal to 37.5 t. And so we should be able to divide both sides by 37.5, and we get that time equals 27 divided by 37.5, and we find it's only 0.72 seconds. Alright, so that's my time. That's the time that it takes to get from the launch point to right here, where it has now gone 27 meters. Okay, so now I can use this time, and I'm going to use it with my y information, now that I have time equals 0.72 seconds. And I'm going to use that to find my y height. And so I'm going to need to use the kinematics equation that uses displacement, time, acceleration, and the initial velocity there. And so that will be this one right here. That looks like y is equal to the initial velocity times the time plus 1/2 at squared. Right, and we should just be able to plug the values in now. So 64.95 times 0.72 plus 1/2 times negative 9.81 times 0.72 squared. And so let's go ahead and put that into our calculator here. So 64.95 times 0.72 plus 0.5 times negative 9.81 times 0.72 squared, and I get 44.22. So the height is 44.22 meters. Okay, now that's not my answer, because the question asks by how much does it clear the top. Well, if the wall is 11 meters, and at this point in time it's 44 meters off the ground, 44 minus 11 would be 33.2 meters. And so it clears the top of the wall by 33.2 meters. There you go.